Now I will prove the handshake theorem. Now here I've stated the handshake theorem a little differently than the Xi book, but it really says the same thing. The reason why I'm saying that the graph must have vertices labeled v1, v2 to vn is because that allows us to do this sum in a way that is done in Calc 2, and I think students in this class will understand that better. Now this really does say that the number of edges is equal to 1/2 times the sum of the degrees. This is the sum of the degrees. This is the number of edges. Right, remember, E is the set of edges. So then the cardinality of E is the cardinality of the set of edges. That's equal to the number of edges. All right, so now for the proof. You'll notice that the proof is very similar to the previous video, except that now I'm not doing it for a specific graph. I'm doing it in general for all graphs. And the thing I want to stress about this proof is that the proof here is really just basically about generalizing our observations from the previous video. So in the previous video, I went into why the handshake theorem was true. And this is because each edge is counted twice when you sum the degrees. So you'll see that'll come into play here. All right, so proof. Let's say consider the edge vi, vj in the graph G. Now, I and j, these are numbers between 1 and n. All right, now this is an edge in the graph, right? So this vertex vi probably is connected to many other vertices by edges, but I don't know exactly what it looks like. I'm just going to consider this one edge. So we might have edges coming off of this thing. I don't know exactly what they look like. I don't know what the graph looks like, but I'm just considering one edge in the graph. All right, the degree of vi counts this edge, vi, vj. The degree of vj counts this edge, vj, vi. Now, as we know that these are exactly the same edge, and it makes sense with the set notation. So since vi, vj equals vj, oops, I guess I'll make that more of a j there, vj, vi, since this edge, the edge from vi to vj, is the same as this edge from vj to vi, the degree of vi and the degree of vj both count the edge vi, vj, or vj, vi, because they're the same thing. So this edge, vi, vj, is counted twice when all degrees are added. So when we sum all the degrees, it gets counted twice. Keep in mind that this is exactly what happened that we saw with the vertex B, the edges of the vertex B in the previous video. Now, since this edge, VI, Vj, is an arbitrary edge, in the graph G, all edges are counted twice by the sum So if each edge is counted twice, then that must mean that the number of edges is equal to 1/2 times the sum of the degrees. And that's the proof.